I'm just going to go over this Unit 4 review packet, and if you want to go along with me, you can, or if you've already done it, which is the best idea, then you can check your work with what I do, and I'll be explaining as I go to help you get ready for your test. So for some reason, there's no number 1, so we're starting with number 2. Jeff sells candy for a choir fundraiser. Chocolate-covered almonds cost $1.25 each, so I'm going to underline that, and mints cost 75 cents each. Let A equal the number of chocolate-covered almonds Jeff sells. Let M equals the number of mints he sells. Write an equation to model the situation if Jeff plans to sell $80 of candy. So because almonds are $1.25 each, I need 1.25, and I'm going to multiply that by A, the number of chocolate-covered almonds. So $1.25 times the number of almonds, and then we would add that together with, where is it, 75, so 0.75 times the number of mints, so times M. So this is the cost of the almonds altogether. This is the cost of the mints altogether, and we want that to equal $80 total for the $80 worth of candy. So that's our equation. Number 3 says graph the equation 8x minus 6y equals 24 on the grid. Show any work you do. Because 8 and negative 6 go into 24 nicely, I'm going to solve by finding the intercepts. So I make my table with 0 for x and 0 for y. When I plug 0 in for x, 8 times 0 is just 0. So my equation is negative 6y equals 24. I divide both sides by negative 6. I get y equals negative 4. And so I put that on my table. And then I graph the point 0, negative 4, just right there. When I plug 0 in for y, I get just the equation 8x equals 24, because 8x minus 0 is just 8x. Divide by 8, I get x equals 3. So that's going to be the point 30. So I graph that right there, and then I make a line. You should use a straight edge, so your line should look better than mine. Number 4, graph the line y equals 2/5 x minus 6 on the grid provided label. So I'll do this one in blue. I'm going to start, it's in slope-intercept form. I'm going to start at negative 6 because that's my y-intercept. So negative 6 on the y-axis is right here. My slope is 2/5, so I go up 2 to the right 5. 1, 2, 3, 4, 5. I could go down 2 and to the left 5. And there it is. Number 5, graph the line y minus 3 equals negative 2 times x plus 1 on the grid provided. This is in point slope form. So the best way to do this is to find the point that's within this equation. It's going to be negative 1 for the x, because it's the opposite of the number with the x in the parentheses, and it's going to be positive 3. So negative 1, 3 is my point. I'll do this one in green. So negative 1, 1, 2, 3, right here. And then my slope is negative 2, which is really negative 2 over 1. So I'm going to go down 2 to the right 1. And I could go up 2 to the left 1. Overall, it has a negative slope because it's falling. All right, those are my 3 lines for 3, 4, and 5. Now number 6. Jack discovered that his magical beanstalk was growing linearly at a rate of 0.35 inches per minute. When you see the word rate, you should think slope. Slope and rate are the same. At 32 minutes, he recorded the height at 150 inches. This is telling me some information that is basically like a point. If I was going to graph this or make a table of this, this is an x value and a y value. And normally, like if I had a table, the independent, or the x, would be the time. So minutes and inches. So at 32 minutes, he's at 150, or the plant is at 150 inches. That's like the point, 32, 150. Okay, so I have a point, and I have a slope, which was 0.35. So if I need to write an equation, I'm going to do a point slope equation, because that's the information I have. And that goes y minus y1 equals m times x minus x1. Oh, I can hardly reach that far. Okay, so I'm just going to plug in my values. It's going to be y minus 150 equals 0.35 times x minus, my cord doesn't go that far, 32. There, okay. And that's my equation. Number 7, write an equation of the line through the points 2253 and 3077. Okay, the first thing I have to do to be able to write an equation is I have to find the slope. And so for that we use the slope formula. So I'm going to do 77 minus 53. That's my change in y. And I'm going to do that over my change in x, which was 30 minus 22. Notice I started with the second point and subtracted the values from the first point. So be careful not to mix those around. You could have done it 53 minus 77 over 22 minus 30. That's okay too. You should get the same thing in the end. 77 minus 53 is, what would that be? 53 up to 77, so there's 7, and then 17 plus 7 is 24. I think that's right. 30 minus 22 is 8. 24 divided by 8 is 3. I hope I did that right. I'm pretty sure I did. Okay, so my slope is 3. Now I'm just going to pick a point and I'm going to do a point slope equation. So I'll do the first point. So I'm going to do y minus 53 equals 3 times x minus 22. So remember it was y minus y1 equals m times x minus x1. That's something you should have memorized for the test. Okay, I'm just looking over it to make sure it looks right. Okay, I guess I'm okay with that for now. Now, number 8, identify which equations are equivalent to y equals 1/2 x minus 4. Show all work you do to convert. Okay, so for all of these, I'm converting to slope-intercept form. So for this one here, it's in standard form. My first step is to get rid of the x term, so I'm going to add 2x. I hope you can read this. It's going to be 4y equals negative 16 plus 2x. Then I'm going to divide everything by 4. And I'm running out of room, but I'm going to get y equals, that's negative 4 plus 1/2 x. So that is equivalent, even though it's in a different order. Negative 4 plus 1/2 x is the same as 1/2 x minus 4. So yes, oh my gosh, I should have done all this work over here. So I'm just going to circle it and put an arrow. Okay, the next equation, y plus 3, now I can't read it, equals 2 times x minus 2. So I'm going to rewrite it over here. Y plus 3 equals 2 times x minus 2. All right, first thing is to distribute the slope. This is in point slope form. Y plus 3 equals 2x minus 4. Now I have to minus this 3. So I'm going to get y equals 2x minus 7. That is not equivalent, so I put a no. 2x is not the same as 1/2 x, and negative 4 is not the same as negative 7. X plus 2y equals 8. Okay, first thing is to subtract x. I get 2y equals 8 minus x, and then I divide everything by 2. So I get y equals 4. X over 2 is the same as 1 over 2x, so minus 1 over 2x. So that actually is equivalent, right? No, I'm joking. It's not. Because my 4 is positive and it's supposed to be negative, and my 1/2 is negative, it's supposed to be positive. No, definitely not equivalent. Okay, the last one, y minus 3 equals 1/2 times x plus 2. So I'm going to distribute the slope first. So I get y minus 3 equals 1/2 x, and then 1/2 times 2 would be 1, so plus 1. And then I add 3 on both sides. So I get y equals 1/2 x plus 4. All right, is that what I wanted? I don't think so, because I wanted 1/2 x minus 4, so no. So the only one that was equivalent was the very first one. All right, let's go to the next page. Alex needs to lose weight for wrestling. Coach Howard makes a plan for him to lose the same amount of weight each week until the first match. His weight is shown in the table below. At what rate is Alex's weight decreasing? All right, so I just need to find the change in y over change in x. I don't really like this color. Okay, so this is x, this is y. It's changing from 196 to 182. That went down 12, I think. Nope, 14. That's what I meant to say. Right, so 182 up to 190 would be 8, and then 6 more is 14. Okay, and then from 2 to 4 it went up 2. So I could have written it like this, 182 minus 196 over 4 minus 2. I get negative 14 over 2, which is negative 7. Okay, sorry, I had to pause because somebody came in. What was I saying? So I guess we found our slope is negative 7. And then when it says at what rate is his weight decreasing, that is, we can make that a fraction, negative 7 over 1. The negative 7 is the pounds, and the 1 is the weeks. So we could say every week his weight goes down 7 pounds. Or every week he loses 7 pounds. That's a lot of weight to lose in a week. The following table shows data collected about pennies. Is the relationship in the table linear? Explain your answer. Okay, so for this to be linear, that would mean it has a constant rate of change or constant change in y over change in x. So we need to find all the changes. So from 223 to 383, I'm going to use a calculator this time, even though I probably could do it mentally. So I do 383 minus 223. It's 160, so it's going up 160. Then from 383 to 623, so 623 minus 383, that's going up 240. And then from 623 to 383, or sorry, 783. So 783 minus 623 is 160 again. Okay, those are all my change in y's. My change in x's, it's going up 60 here, it's going up 90 here, and it's going up 60 here. So I'm going to write a bunch of fractions and see if they're equivalent. So change in y is 160 when the change in x was 60. Change in y was 240 when the change of x was 90. And then 160 over 60. And so 160 over 60, these are the same. I have to see if that's the same as 240 over 90. So if I was to reduce those, or I could even just write it as a decimal, it's 2.6 repeating if I use my calculator. 240 divided by 90 is also 2.6 repeating. They're all 2.6 repeating over 1. So yes, it is linear. Yes, linear, constant rate of change. Of 2.6 repeating over 1, or as a fraction, I could have left it as a fraction, and that would be, that's 2 2/3, so 8/3. All right, the Kratt brothers, Chris and Martin, sell animal cookies downtown to people walking by. Chris typically sells more cookies every hour than Martin. A graph of their earnings from last night is shown. What are the slopes of each line? What do these slopes mean in this situation? Okay, so the slope of, I'll do the black line first. So I'm going to find 2 points on that line. So it looks like, actually, here's a point, here's a point, here's a point. There's lots of nice points that I could choose from. So from this first one to the second one, it's going up 10 and over 2. So that is the same as 5 over 1. So there's 5 over 1, and then the other one, the blue one, here's a point, and then here's another point, and it's going up 20 over 2, which is 10 over 1. Okay, what do they mean in this situation? So let's see, it says that Chris sells more every hour. So the steeper line is going to be Chris. And then the other line will be Martin. So what these mean, the 5 over 1 means Martin sells 5 cookies every hour. Five cookies per hour. There's not enough room here. Chris sells, I'm going to go up here. Chris sells 10 cookies per hour. Okay. What is the slope of the line perpendicular to the line y equals 2/5 x minus 6? Perpendicular has opposite reciprocal slope. So that means I'm going to take 2/5 and I'm going to turn it upside down, and then I'm going to make it negative. So negative 5/2 would be the slope of the line perpendicular. What is the slope of the line parallel to the line y equals 8/7 x plus 6? Parallel means same slope. So if this line has a slope of 8/7, a parallel line would also have a slope of 8/7. Number 6, Ruth's account balance on her credit card can be modeled by the function b of m equals 75m minus 1500, where b is the balance in dollars and m is the number of months since she went on a big shopping spree. What is the vertical intercept, also known as y-intercept, for this situation? So the y-intercept, this is like y equals mx plus b. And so in this case, the b, or the y-intercept, is the negative 1500. Or we could write that as the point 0, comma, negative 1500. What does it mean for Ruth? It's telling us when x is 0, or in this case when m is 0, so at 0 months, it's telling us the balance on her credit card. So we could say at 0 months, her balance on her credit card is negative $1,500. That means she's in debt, $1,500, right after her shopping spree, 0 months since her shopping spree. So she spent $1,500. What is the slope for this situation, and what does it mean for Ruth? The slope is 75, and that's like 75 over 1. And if we think of it as change in y over change in x, in this case, the x, or it's called m here, our independent variable is m, that's 1 month, and then this was dollars. So it means basically her balance is going up by $75 every month. I don't think it should be her, well, I guess if you think that balance is what she owes. No, that doesn't make sense. I wonder if this is worded funny. Yeah, no, I don't know. Sorry, I'm getting confused right now. So she owes 1,500 because she has negative 1,500. What she owes is going down by 75. I don't know. I think what we can say is that she's paying $75. She pays $75 towards her credit card every month. Which really means her balance is going down. It's kind of funny because with the negatives and whatnot. Sorry, I don't have this like perfectly practiced. I'm just rough drafting it here. But okay, we're gonna keep going. Hopefully that's okay with you. We can talk about it in class if you're confused. Next page. Describe how changing the value 12 to a value of 18 in the equation y equals 4/5 x plus 12 will affect the graph. So this is the y-intercept. And if I'm changing it from 12 to 18, imagine the graph. It's going to be something like, say that's at 12, it's going to scoot up and be like that. So we would say the line shifts up, and it's going up by 6 units because 18 is 6 more than 12. Give representations to fit each criteria. So we want something that has a y-intercept of 2. So I need to graph a table and an equation. So I'll start with x at, when x is 0, y has to be 2. And I can just decide how I want my pattern, but I know my graph is going to be right here. I think I'll keep it easy, and I'll say that it's changing with a slope of 1. So when x goes up 1, y goes up 1. So 1 and 3, 2, 3, 4, and then it's going to be 3, 4, 5, 6. So when I graph that, I've got 1, 3, 2, 4, 3, 5, and then I can go backwards as well. Okay, so here's my line. I've got my table. My equation would be y equals, my slope was 1, so 1x is just x plus 2. All right. The next thing, it has to have a -3 in its domain. That means it needs an x value of -3. So I'll put -3 on my table. I'm just going to count by ones and go -2, -1, 0, 1. I can keep it easy again, and I can make my slope be 1 still. So it doesn't say what my y-intercept has to be. So I think I'll make my y-intercept be 0. So that would be the point 0, 0. And then if my slope is 1, it's going to go up by 1, and then it's going to go down by 1. So if I graph these points, and you could do something totally different. I'm just doing what first comes to my head. So point 0, 0, -1, -1, -2, -2, -3, -3, 1, 1, 2, 2, 3, 3. So it's just a diagonal line. This is actually the parent function, if you remember me talking about that. The equation for this would be y equals, so its slope was 1, so 1x. Its y-intercept was 0. So I could say y equals 1x plus 0, but that simplifies to just y equals x. And see, all my x values and y values are the same, so it makes sense that y equals x if you look at the table. And it does have a -3 in its domain because that's this point right here and this point right here on the table. Okay, now I need one with a slope of 2. It doesn't really say anything else, so I'm going to say I'll start at -2, -1, 0, 1, 2, and I'll just start with, I want to make it fit my graph, so I'll have it start at -4 when x is -2, and then it's got to add 2 every time that x adds 1. So it's going to go to -2, and then up to 0, and up to 2, and up to 4. So if I graph those, -2, -4, -1, -2, 0, 0, 1, 2, 2, 4. All right, this has a slope of 2. It's going up 2 and over 1. And my equation for this would be y equals, my slope was 2, so 2x plus my y-intercept is 0. So that actually just simplifies to y equals 2x. All right, again, there's so many different things you could have put, but I just put what I wanted to, but it's not the only right thing. Okay, the last page. Sarah and Tracy are meeting up for a ski trip. They each drove from their own home to the mountain. Sarah recorded her distances and times in a table. Tracy used an app to graph her distances and times. All right, so we've got the table and the graph. Sarah and Tracy. Number 1 says find Tracy's speed over the following time periods. So from 0 to 70. So Tracy's the one with the graph. So from 0 to 70, which is right here, she went up 60 and over 70. So her speed is also the same thing as the slope because it's distance over time. So 60 over 70. And if I wanted to reduce that, that's 6/7, which as a unit rate, 60 divided by 70 is about 0.86, which is miles per 1 minute. Or I could say 60 miles in 70 minutes. I could say it either way. From 70 to 110 in that domain, that's from here to here, so it's steeper. So right here she's at 60 and she's going up to 140. So that is a change of 80. And it went over from 70 to 110, right? And that's a change of 40. So 80 over 40, so she went 80 miles in 40 minutes, and that reduces to 2. So that's 2 miles for every 1 minute. And then from 110 to 170, let's see, so that's Here she's at 140. She's going up. What is that? Is that halfway between these two? 195? I can't even see that. Let me look at the paper. Yeah, that's 195. Okay. I'm going to write these as points. This was 110, 140. And this is the point, 170, 195. So it's going from 140 to 195. That's a change of 55. And it went over 60. 55 over 60. And that is, so 55 miles in 60 minutes. And that's 0.92 about miles per minute. Okay, so I found her speed. What was the fastest? Looks like the middle section. So from 70 to 110 minutes. She was going 2 miles every minute. Compared with the other two, which you can see right above since I showed all my work. Also, we could say it's the steepest line. And the steepest line means it has the highest slope. Okay, give the domain and range of Sarah's information. So Sarah's is the one with the table. And normally we would give tables, we consider that discrete data. So I'm not 100% sure. I need to talk to the other teachers and see what we want to do. Because we know she didn't only go those few, those like 1, 2, 3, 4, those 5 distances and those 5 times. She really traveled throughout. It's really a continuous situation. So I feel like we should treat it continuous. So the domain, I'm going to list the lowest and the highest distance traveled. She goes from 0 to 225. And then the range is the time traveled. You know what? It says backwards. Time should come first, and distance should come second, because time is the independent, which should be the x. Distance should be the y. So this really should be reversed. So I might tell you that, except I won't be here on Monday, so maybe somebody will tell you that. This is too bad. We'll talk about it before your test, but the way it's given here, the domain is 0 to 225. The range would be 0 to 265. We may switch those because they probably should be switched, but the way they're listed now, and what is that? What does the domain mean? It means she traveled between 0 and 225 miles. The range means she traveled between 0 and 265 minutes. And then I should give the domain and range for Tracy, but I actually have to go to a meeting right now. I didn't think this was going to take so long. So we'll go over that in class. I hope that this helped some of you who watched it. Come with questions before the test. And thank you for watching. Goodbye.